I think Google was just not brave enough. That technology regulators are going to kill us. And OpenAI has no problem like that. Said, well, let's get that technology in the hands of the people. It's good enough.
Playing with large language models. Okay, what do I do?
But think about humans. Our brain consumes tens of watts. I don't know, maybe 30 watts at maximum, right? Language, reasoning, logic, like all at the same time, all in parallel.
Multimodal. Right? What happens if, let's say, US does get behind?
It's a weird feeling to feel like you're behind and you actually start to depend on someone else with these critical technologies.
Yeah. Hey, I'm more than that. I'm more than what I do. I love ballet.
Here people invested into game-changing technologies and they're willing to take risk.
This is once again Silkroad Podcast. Silkroad Podcast is a podcast about wonderful founders building next generation products and companies. Today with us, Gennady Pekhimenko. Gennady is the CEO and founder of CentML. CentML is a wonderful company from Canada, working on cutting edge technologies. Guess in what field? Yeah, Gennady, welcome.
Yeah, thanks a lot. Great opportunity for me to talk about our company. Thanks a lot for the invitation.
Yeah, Gennady, let's talk about CentML. What CentML is, what are you currently working on, and ideally, who are your clients?
Yeah, so CentML was built, and its main target is optimizing machine learning workloads and GenAI workloads. So the primary goal is to reduce the cost, to improve performance, to reduce power and power consumption, energy emissions of these very hungry workloads. And this is what drives our innovation, our products. So CentML exists for about 2.5 years, and we built several products in the space that helps people to optimize their deployment of large language models. So we have a product called CServe that can dramatically reduce the cost of deploying large language models, right? We also had products that helps to deploy and fine-tune a lot of other machine learning models you might be interested. So this is the major focus of the company.
Yeah. All right. So let's talk about your clients from the use case perspective. Who do I have to be ideally in order for me to get to try? Because if I'm an individual user, I might not be able to use, there wouldn't be use case for me, right?
Yeah, yes and no. So for a long time we focus, and still the primary focus is businesses, right? It's business to business, go-to-market motion. So we sell our software for companies that actually build their own models and want to deploy them, right? So the customers are essentially enterprises. So the examples are Deloitte, that doesn't need a lot of introduction. The companies like Redapt, which is a major reseller of Dell hardware, a lot of startups, and a lot of medium-sized and cloud providers and so-called neo-clouds. So companies like Cruiser, Navius, and others that actually starts to deploy and run a lot of AI workloads on their hardware. But all that said, we recently released a product just last week that allows to people that have a lot of knowledge about AI still to use it the same way they use ChatGPT. So we make publicly available serverless endpoints. So if you go to app.centml.ai, you essentially get an interface where you can pick popular open source models like Llama, like really large Llama. And for the people who have no expertise, there is an endpoint you can just chat with it. So you go and chat it the same way you chat with ChatGPT. So I have friends, relatives who are already using it instead of ChatGPT, and they pick their favorite model. So even and we provide some free credits, $10.
Yeah.
And $10 doesn't sound like a lot, but realistically, there's many thousands of queries you can run.
Okay.
Right?
Yeah. I saw that. I think it's a good job Ermek is doing that. I saw and I got interesting, but I didn't get the heart to go and try it out. And I saw playing with large language models. Okay, what do I do? Okay, I don't have a lot of time right now. Maybe later. But that so what would be the use case for this individual case, and why did you why did you start this? Because like your main focus is still business, and the main the income source are the businesses, right?
Yeah, so there are several reasons why we released this new product. So first of all, we get level of maturity where it's actually not difficult, right? Another thing is it's actually very important to get at the early stage. Majority of the customers and our competitors are very early stage at this point. Like the products that exist in the space, they usually don't exist for more than a year or so, right?
Mm-hmm.
So essentially, people want to try out and get the feedback. So it's important for us to get the feedback from ordinary users, right, on how they see this. They can tell how they like the models. They can tell us which models they like, and they can request new models to appear there. So it also helps promoting open source models in general. Similarly to how other vendors promoted Llama models and Mistral models, we want to contribute as well to that trend. So the models will be publicly available, not won't be only proprietary models, right, that would, use your data and train and like utilize you as a source. Like we don't do this. And another reason is whenever we talk even to the business customers, very frequently it's like how we can quickly compare against everyone else.
Mm-hmm.
And instead of setting up the environment for testing, you just make it publicly available.
Yeah.
So they go and try it out. And then for the people that are more advanced, we release the version where you can try your own models,
Mm-hmm.
right? Where you can try set up your own containers. We also allow you to pick the hardware you want. So we actually we try to make some of the features we built for enterprises being visible for regular developers. So I don't think a lot of people, like regular customers, will use those ones, but that developers, ML developers, data scientists would start to use it because they all want to save on costs. They want to try out different hardwares, and that's something we offer.
Okay, yeah. So from what you're describing, you're on Jan LeCun team on the open source. You're for open source.
Yeah, it's like we definitely not all of our products open source, but do we contribute a lot to open source ourselves, and we believe that having open source models really critical because people need to have options, and they if they want to build up something on their own IP, they want to make sure that can be done safely. So it's important for the companies. So companies like Deloitte, they're going to build their own IP. They don't want to sit on just like, say, OpenAI only APIs, because it means you don't really have control over your own stack. With us, you do, right? And important part of that is making sure those open source models are popular, competitive, and people can have access to them.
Okay.
Like in their research, academic, and data science community, everyone knows about Llama, but go ask a regular person on the street, they would know about ChatGPT. They don't necessarily know about Llama.
Mm-hmm.
Like we want to make sure that open source models are as popular and as well known right now, and part of that is actually promoting them enough because their quality of those models from AI perspective is already really high. They are actually competitive against proprietary models like GPT-4 or Claude models from Anthropic. So we just need to be promoted more.
All right. So I'm not gonna ask you the question of like what's the future of AGI, but I'm gonna ask you what's the future of large language models. So do you see it as mainly open source, where like there exists some companies who hold proprietary models, but mainly for the companies, and like now countries are starting getting into the LLM game. We were yesterday we're talking about like the representative, the team in Nazarbayev University working on large language models, which is like Kazakh LLM. So what do you think the future for language models?
I do think that large language models will find a lot of good use cases, right? They already started to find them. So I think for LLMs, the future is quite bright. They might change and will adopt to the necessities and the new advancement. But the key fact that we were actually able to capture for the first time in a long time something we were always attributed to just humans have, which is a language. It's a big thing, and I don't think it's going to disappear. I think it's just going to go through evolution. So now we're going towards multimodal stuff. Like you've seen a lot of multimodals where we can work with images and videos. This is an important evolution of that, and like the LLMs themselves will change over time. But I don't think they're gonna go away anytime soon, because they literally find, like I see customers using them for the use cases they would never go back to use humans. Like for example, finding frauds in bank data. Like people use, like big banks used to use many people to do it. Now those large language models are really good to absorb a lot of text and infer information very easily, and they're not tired. They don't need to be paid huge wages. Like they are quite efficient at doing that type of manipulation. So I think they're definitely going to have a future use case, even though they might evolve over time, right? So I do think we're going to see them. How quickly they adopt is it's an open question. I think right now most of these models are still based on the idea from 2017, based on the attention is all you need work from Google and several other people that are all over the place right now in different companies. I think there would be an evolution. There would be new ideas come up. They would look differently over time. But the key idea that we want to be able to capture what the language is, and generate text the way the humans talk, that would be there. And you touch upon a very important point. Then there is definitely interest in supporting more languages beyond English and like West European languages, right? So you mentioned Kazakh language. There is a huge initiative in Middle East, like in Dubai. They had several companies that working on making large language model for Arabic languages, right? There is initiatives right now in China and other countries. So all of those models will enrich and make it possible to use like in any language, right? Essentially making sure like if you had enough training data, it can be usable.
So my next question comes from this, actually. What do you think the future of languages here is in the case? The more use case, the more use we make with large language models on our day-to-day lives, it is getting more and more on our queries. Like now there is an Apple Intelligence on our phones, like that we are going there. Do you think it will accelerate the disappearance of smaller languages? Like for instance, if we do not work on those smaller languages, by smaller I mean like Uzbek language, which is like 80 million people worldwide speak. Like Kazakh language, I think about like 30-40 million people speak worldwide. But there are even smaller languages where fewer than 1 million people speak. What do you think the future of languages would look like in this case, where the use of AI and the best models are going to be the main languages? The research is done and the language models are trained. I'm thinking English, Chinese, and other languages.
The way I think about Gennady and LLM in particular, it's like a tool, and every tool can be used in a good way and in a bad way, right? So I think the aspects of the relatively small languages, I wouldn't call even Kazakh language like that small. Like
no, it's not. It's not. That's what, yeah.
But there is that pressure exists way before LLM were invented. The whole globalization process makes sure that the bigger languages gets bigger, right? And they do affect things. But in a way, similarly to how we try to preserve the planet and animals there, those language models can preserve the knowledge of the languages. They might disappear and under danger, because as soon as you let them get the training data, they would never forget, right? You just have the data in your training corpus and you can like just add more inputs, right? Another interesting thing is right now, at the beginning, a lot of smaller languages didn't have enough training data, and that was the problem to train the models for them. Compute was a problem. Compute is actually something we're working on to help people with, like simplify the process, make it cheaper. But I actually think another direction that's right now happening in AI is synthetic data. So the AI would actually learn from how humans talk, and to actually making sure there's a good language models for those languages. It would actually start to synthesize more and more training data to learn from itself, right?
Yeah.
Like so-called reinforcement learning approaches. And this way it would actually can create a very powerful languages. And if we as a humans don't care about certain languages and they disappear, at least they would be preserved in that form, right? So in a way, it's the way, like similarly how we try to preserve DNA of the animals that got extinct, and we just hope we get technology eventually to get them back to life. So it might the same happen with different languages, right? So it actually might be, if you use it properly, it can be a great tool to preserve those languages.
Yeah. So we should have soon something like UN initiative on training language models on
smaller languages,
Yeah.
yes, especially when the technology get to the level you would need less training data, right? Or you, for example, if you can repurpose some, like for example, if the language is unique, but it has some similar languages around it, like you can learn some core abstract, because like all human languages have some similarities and there are more and less dependent family groups of the languages. So using that information from NLP theory and others, we can like learn core of the language, and then specific of the language we train on that specific data. So yeah, I think it's definitely something that will eventually can be used if there is an interest in people, and we would provide the tool.
Yeah, can you explain me the process of like how will it become easier to train LLMs on smaller like the languages spoken by a smaller population by improving the quality of the existing large language models? How one affects the other?
Yeah. So first of all, it's important to understand on what was achieved already. Because let's put it in the perspective. When the first models appear in Gennadiy space, the first big model was, say, I think like something like 175 billion parameter, like one of the first large models. Right now there are trillion parameter models. And there was certain intelligence associated with how good that model is, like one of the LU metrics, like level of intelligence. So right now, we can get the same quality of output for the model that is only 1 to 3 billion parameters. So in just 3 to 4 years, the number of parameters needed and the amount of training data needed to actually learn, that information was reduced by 2 orders of magnitude, right? So what does it mean? It means that as we learn more, we understand how to learn way more with way less compute, with way less parameters, so that the model that didn't just have enough training data and were just considered just too tiny would now be amenable for this approach. And it's not that we're done. Like, just think from the perspective of how we as humans learn languages. We actually don't consume the whole corpus of all the internet and all the books to learn our languages. So there's a hell of a lot of possibilities to improve from algorithmic standpoint on how we learn languages, right? So it's like, I don't need, like when I teach my kids, you just teach by a few examples and they learn the structure of the language, all of that, not by reading all the books that exist, right? So the improvements will come, and that as this improvement comes on the major models, because it's driven by cost. People like to train those models, but they want to reduce the costs. So it means they would keep innovating. As they innovate and reduce their bar of entrance to training new models, more and more languages would be easier to train. And it would require less data, it would require less compute, less time. So it would be easier to train like than some library. And we can commoditize a lot of that process eventually over years. It means that somebody should just excited about their like own language, that they're unique. Because this is now like just cost like, I don't know, a few $100s. Right now, like training large GPT model is like $10 million, if not $100 million. But it will keep go down, right? Like there is a lot of trends there. Like training gets cheaper over time, even though people, put more and more data in it. Deployment also becomes cheaper. Like for example, we observed that in around 12 months, the cost of deploying large language models go down by about 10. I guess it goes down by about 2x every 4 months. It's ridiculous. It's a very huge level of improvement, and it's about the size of the models. It's about the speed of the models and the cost of compute. So all of that is going to optimize and go down, so get commoditized. And what helps with that is the interest. It becomes a mass market, and a lot of things will go down. So it becomes a technology that easily available.
So thank you so much for very detailed explanation. I hope our users will love it. And the next follow-up questions is that we talked several components. In order to large language models to get cheaper, to train them, there are two components. It's becoming the newer language models are becoming more efficient, and it requires less parameters to achieve the same results which we are achieving today. And the second aspect is the cost of compute, which is directly relevant to whatever NVIDIA is doing, whatever the next chip making company is doing. They're working on a better design, better architecture. And the third, is the cost of electricity, right? So what do you think should happen in order for large language models to become so commoditized that like we use it? I don't know. Can we use it like? What's the most abundant thing on Earth?
Electricity.
Is it?
I mean, isn't that something that's commoditized?
Yeah. What needs to happen in cheap manufacturing, and what needs to happen in production of electricity, so that we reach to the level where, like, the almost the future, the sci-fi movie level where everything is done by AI and there's not much human involvement.
Yeah, like a lot of things you touch upon here. So there are a few things. There is training new models, building new models, and deployment. Yeah. Right. So let's separate. Like first of all, training. I'll just remind the listeners of the podcast what are the three major key pillars in training. So first of all, you need a model and an algorithm. That's what's deep learning, transformer models, everything you associate with the model itself and the process of training. That's one big pillar. Without that, nothing is possible because it drives what to do. But that model needs two inputs. First, it needs a lot of data, and then it needs software and hardware on which to run. Right? Those three major pillars. So with these three pillars, this is how our deep learning operates right now. This is the best we're able to do so far. But if you think about it, how well we're doing versus how we're doing as humans, it's a huge gap. And I'll talk about power and energy. It's very important consideration. But think about humans. Our brain consumes tens of watts. I don't remember, maybe 30 watts at maximum, right? And it actually can do a lot of different models and inferences on like language, reasoning, logic, like all at the same time, all in parallel.
Multimodal.
Right? So multimodal and in parallel across multiple different channels. Like it's quite efficient, right? It's very power efficient. So it doesn't need the huge nuclear reactors that Google's need for their new models, right? Yeah. So what it means, there's a huge room of improvement eventually there, like to utilize this model. And as we go in the step, there's orders of magnitude of improvement is ahead of us to learn, even to repeat what the humans can do, not saying about inventing something beyond human capabilities. Now that's years away from us, right? What happened realistically right now is the model base and the size of the models outperform the capabilities of compute, speed, and power grid in the United States at least. So how does that look like? So around 2017, when attention models were invented, the model training was like thousands of dollars to train. Like even university can still afford it, right? Very quickly, about every year, the size of this model starts to grow. Like what people realize, if you feed more data into this model, they keep learning. This is, by the way, not a not normal thing. A lot of models and algorithms stop working at a certain scale. What was very unique about deep learning and transformer models, they seem to seemingly can improve endlessly with more data. So the first transformer was trained on like wiki data because it was publicly available. And the author, like I know one of the co-authors of that paper, Aidan Gomez, who is CEO of Cohere, he said what was shocked them, they've given them more data, models keeps getting better and better. And that's what OpenAI leverage. They keep throwing in more and more data that adjust the model. And the models keep growing about 10x each year. What's the problem with it? It's great that it's like you can feed more data and increase the size of parameters more, but the compute improve at the very best 2x a year. So you're getting about 5x delta each year. So what does that mean? So instead of you training on 100 GPUs, you were starting to train, or TPUs, you were starting to train on thousands, tens of thousands. Now, OpenAI and Matter, not OpenAI, Musk's XAI, And Meta has a cluster
Yeah.
with 100,000 GPUs in them. That's the biggest supercomputers in the world. Like, just think about the scale of this thing.
Yeah.
Because of that huge delta that we had, the growth of the model with the improvement in compute, there was such a big disparity. Like, NVIDIA was improving, but at the best they can improve like 2x a year, and the models were growing much faster than that. We accumulated in 5-6 years a million x delta in mismatch in cost, and we need to compensate it moving forward, right?
Yeah.
Even if the model don't grow as much every year anymore, it's still a huge delta that we need to consume. Because of that, there is a transition period then to train these foundational models, and even to serve those models, a lot of power and electricity would be needed.
Mm-hmm.
And you can already see this year alone, the most latest news were about Google, and I think Amazon was trying to get approvals to use nuclear reactors for the new data centers. And why? It's just not enough electricity in US in the density needed. So it's like one of the problem is that there is electricity around, but it's not at the density. Like data center needs it's very close in a huge abundance, not like distributed all across the country with say solar panels. So it's not available at where you want in the density you want. And it's very hard to get it with majority of technologies, the density you need, right?
Even with nuclear.
With nuclear you can, but you need the nuclear was very delayed for many years in US. We didn't progress that well in the country for a long time. So there is like a lot of regulations and limitations on how to use it. It's not that easy, just let me go buy another nuclear reactor nearby. By the way, like yesterday I was in this big dinner event called CFR where like we discussed AI and energy implications with some of the people working in DC, and like they would discuss, okay, should we use gas? Should we use nuclear? Like what are the options? What is the grid possibilities? So like I learned new things for myself. I learned, for example, that we had way more power and energy available in general. We just can't consume it. It's not reachable through the network. Like we cannot bring them to the point I want. It's just if the solar panel is there and I won't need my energy there, I cannot just transmit it easily, right? There's a lot of transmission limitations. So for the foreseeable, like whatever next 5 years, it's going to be a limiting factor. And like I'm pretty sure that the new administration, like in US, is going to pay a lot of attention because it's a matter of national security. If you don't get enough power in US to train the state-of-the-art model, you'll get behind, China or like even Middle East potentially. So you need to figure it out. You need to get enough power, and right now it's a limiting factor.
So 2 questions, follow-up questions on that. What's just to put it simply, what's going to happen if US gets behind? Well, like everyone talks about like getting behind, we shouldn't get behind China or whoever's working on it. Like what happens if let's say US does get behind? I'm not sure 4 years is enough to unwind some of the laws and regulations which were put in place, first of all, on the regulation of nuclear. I think that from the construction standpoint, I think it would be a difficult job to unwind some of the regulations and
but like you need to go into this. Well, first of all, what the implication? It's like the implications of AI is vast, right? Like you can think anywhere from the most dangerous ones, like military implications, like drones, swarms, like and all of that is a possibility to use AI, and you want to make sure you have the best models, like than your competition. Then technological advancement, like US for a long time never been in a position that they are significantly behind than anyone in the key world technologies, and like it's a weird feeling to feel like you're behind and you actually start to depend on someone else with this critical technologies. So it's a matter of national security, I'm pretty sure, for any government right now. And like all other countries beyond US are worried about that and how their languages are covered, like what they can do, right? So it's definitely meant. Right now it's an interesting situation where US has an edge, for example, in chip manufacturing. But it's not solely their own, so they had all the key technologies, but they do manufacture in Taiwan mostly, right, at TSMC. But China has no technology to build chips as advanced themselves as of now, right? So there is a years and years that China would need to close the gap. But at the same time, China has an advantage in the resources, like they had hydroelectric power and like less regulatory limitations, right? So it's easier for them to get resources into the problem, right? And for their growing economy. So it is something. There is advantage US has, but there is also some advantages that China might have. So in ideal world, I would prefer that everyone would partner, but reality is it's not. There is a competition, and I'm pretty sure there will be a lot of decisions made based on that competition, right now. So there's going to be a lot of investments into startups. There's going to be a lot of investments into the tech company to make sure you have that technology, right?
Yeah. But we're not talking about like 20s, 1940s, 30s, whatever. So what's happening there? We have big corporations. So for instance, if the electricity and the regulations are stopping Google from training the best models, they can take the shop and open the shop in, let's say, Canada or United Arab Emirates. They are promising the most. Like crypto was there, they opened it up, the companies started popping up. Like, why do you think it's important, and why do you think it should happen in US?
That's a great question. Yeah. So it's not just like it's many different opinions here. So first of all, for a long time, US outsourcing a lot of things abroad, and now they reached the level where they understand they're dependent on others on the critical technologies. And it might be okay if everything is safe and operational, but it might not if it's just only one little island produces all the key chips that might not be particularly safe, right? Especially if its island is contested, right? So another aspect here that's very important to cover is where like how much of the IP you want to have generated here versus in other countries. Another aspect is again which of the technologies you want to share. Like for example, if you want, there's like different regulations. For example, in Europe, the data has to stay in European generated data has to stay in Europe, right? So it means you already had to take this into account. And then I'm pretty sure eventually there would be same limitations in US. So if you want to train the data on and your Google on US customers or US clients, it has to happen in US, right? So you have to have that resources in here. And also it's about the AP associated with it. So yes, theoretically you can use resources of the rest of the planet, but there are going to be a lot of limitations, right? So you do want to have some core capabilities so that if something happens, you're actually independent and can do majority of that yourself. So, and again, I expect even more of that trend with the new administration where they try to move more things back into Canada, also more into US. And yes, with Canada it's easier, and like with Mexico it's an NAFTA deal, so things can do. But again, like Canada by US standards in terms of power and resources, it's relatively small, right? So it might not satisfy all the demand. In fact, Canada has right now way less compute than US, like in proportion to the size, like really small. So Canada is trying to figure it out. They had a new program for that.
Yeah, before we move on to discussing like the Canada versus the Silicon Valley, like how do you like what's your what do you think of the recent changes in Silicon Valley in general and tech in general, where we're like America first, build stuff, I don't know, whatever, bring jobs back, whatever's happening in technology now, even the looking back at YC, Andreessen Horowitz, they're like famously US venture VCs did not invest in arms and weapons of mass destruction or companies in that sector. Now it's getting more and more obvious that they are willing and starting to voice those preferences that they're ready and they're actually doing it. What do you think of those changes in Silicon Valley in general?
I mean, changes are definitely happening. Like it's hard for me to say at what scale, right? There are, to what it matters, Silicon Valley is still the place where most of their, a lot of IT talent goes, right? Yeah, there was some departures, like Elon Musk's move his company out of here, but majority of people are still here. And there is a reason why we, for example, CentML opened our second office actually in Silicon Valley, in Palo Alto, right? Because there is the talent that only exists here, and there's resources here, like there's VCs, right? There's startup ecosystem, there's like events every day here happening that are relevant to us. there are people that we want to hire that are here, right? So, and there are customers of our product. Like nowhere in the world you're gonna drive like in San Francisco, and all the billboard will be about AI. Like if every time I go there, I post pictures and say, like, can you imagine this in Toronto, right? It's a very unique place, and you want to leverage that. And US is well deserved, like, to build an ecosystem that have like that, and nobody was able to replicate it so far, right? So how is it going to change moving forward and all the trend right now? It's hard to say. I think there is a understanding in US that they have to care of their own people, not only about their national interest abroad. So I think that partially reflects what's happened in recent, trend and votes and all of that, right? But I think it comes in waves and goes up and down. I don't think US is the country that's going to isolate itself from the rest of the world. It always want to play a big role. It's always going to play one of the dominant role in the world. So I don't think that's going to dramatically change. So I think that the shift would be towards making sure we can actually build the key technology for their important things in US. And we had a lot of IP associated with it in the country, because these are high-tech technology jobs. They're very important. I think there's a whole books written about how TSMC become dominant and why is it in Taiwan and all of that. I'm pretty sure like some of their decisions made by previous administration that were micro-optimizing things locally, but then make a big strategic mistake at the end. That's a good example of that. And I think they try to fix some of that moving forward.
It sounds great. So you mentioned about talent, the people you want to hire, the best AI talent being in Silicon Valley. Why do you think of that? Why do you think we've come that the best talent is in Silicon Valley right now, especially in AI? Like everybody who is working or who is doing something in AI, like it seems all the AI companies are clustered in Silicon Valley, especially in San Francisco.
I mean it's not new. Like there were multiple booms there. So there were a time where hardware was booming. Right, the chips were invented. There were a lot of those companies there, like in 70s and 80s, and then software boom, right? So it's not that just AI it's unique in that sense. It's the biggest. There are other centers of gravity that exist in US. It would be Seattle, right, in Texas, Austin, and then in Canada it would be Toronto and Montreal. They are hotbeds of AI for historical reasons. Like for a long time, US, like say 1890s, when there was like winter period for AI, a lot of the foundational support for those things, like for Geoffrey Hinton, was in Canada. So that's a lot of AI that was invented, including deep learning, was actually invented in Canada. But overall, there's after something becomes trendy, like people come here for the ecosystem. So it means there are people with the experience, right, and relevant experience in growing the companies. There's capital here in VCs, and it might sound very abstract, but let me give you one example. Like when I fundraised myself, right, I thought about what's the difference between meeting a VC from Bay Area and meeting a VC from New York, for example, right? It seems like, well, they all have capital, like what's the difference? Well, you have a few meetings and very quickly you realize that the desire to take a risk for a higher reward is much more high here. So for example, in New York, a lot of the VCs are very fintech oriented. So they had a lot of reference points on what kind of IRR, like annual revenue, you have to ask for that much money. And for example, in AI, the companies were growing at a totally different pace. So for them, we are like asking too much, like we're having too high of a valuation, too much money asked before we see the traction. But here it's totally different. Like here people invested into game-changing technologies and they're willing to take risk. Here people give hundreds of millions to companies that have no IRR, right? You've seen like some of the recent startup created by people that exited OpenAI. They raised like, I don't know, $1 billion valuations, like $1 billion even rounds by just the name, like no product, just by the names of founders and the abilities to build things. And if you look at their venture investors, they're local, a lot of them are local. So essentially that talent, right? And we did tell them, like I did consider to open my I know I need a second office in US because the customers, like a client base, all of that. But then we look at Seattle, New York, Austin, and there's just not enough people with the skill set we need. And it's not pure AI, like we're looking in AI systems. But essentially like the people, that's not just AI, it's the people who actually build things run efficiently on AI. And not surprisingly, there's very few companies who did it. It's like Nvidia, it's Google, it's Matter. And well, where are those people sitting? They're all here, right? There is a little bit of people all, and we do try to hire them as well. And it's not like you intentionally would come here. It's like here people are very expensive. The talent here is also spoiled. They had like all the opportunities in the world to go change the job easily if they want to. But nevertheless, it's just not enough people of that competence, especially if you look for more senior talent. Then like junior talent in AI exists in many locations in the world right now, including Toronto, and we leverage that. But just not enough, simply not enough. Like there's the highest density, right? On paper, New York has a lot of software developers, but when you start to look at their profiles, this is all like fintech type of development. So it's totally different from what we're building.
Yeah, that's thank you for a detailed response. It's really interesting. You explained the reasoning why you had to open the second office in US. This is great. You touched on a point on key moments for in AI development in history. Like we as a users, like the consumers of the end product, we associate the rise of AI with OpenAI deploying the ChatGPT. Like everybody does. Like whoever you ask. Like I think there is a very small minority of people who know the history. So for our listeners to understand, what are the really important key historical moments for AI? If you can name a couple of them, starting from early periods. We don't have to go as early as like the 1950s or 1920s. I don't know. But
so if I don't go to very ancient times, but say start with the big contributions. Like the first one I remember myself when I was actually an undergrad back at Moscow State University. So I learned about the algorithm called backpropagation, and that was invented by Jeff Hinton in end of 80s, right? With co-authors, he was still in US at CMU. So there I learned there is a mechanism to learn from the data such that you never actually had to formally prescribe something. That was like, for me, I was like, I think my fourth year undergrad, I was like, oh my God, you can learn from the data without formally writing before everything I learned, was like, you need to write a mathematical function for the learning thing, it's like some complicated, and it would try to learn parameters, adjust parameters to that. Here it's like, you just give it an input, then you look at the output, you know what the right output is, and you say like, let's adjust the parameters accordingly. So it's like back and forth. That's why it's called backpropagation. That's the first big invention. There's no training right now. That's still all the training right now is based on this core principle. It's called backward propagation. There's a forward pass and a backward pass. And it works a little bit like our brain. Like when we teach kids, we don't tell them what the formula is to recognize a dog or a cat. We shows you, here's an example, what the dog looks like. You watch it with your own eyes, and I ask you, what is it? And if you say wrong, I reinforce it and say like, no, your answer is wrong. So what happens, your neurons in your brain and parameters, they adjust it. They adjust it so the next time you see something similar, you're going to actually get correct output. So backpropagation works the same principle. So because of that, it's like a black box, but you really don't know what the parameters inside that. It doesn't actually matter for you. You just adjust them, and that helps you to learn. So that was one of the biggest breakthrough. The second biggest breakthrough, and that was the first, with this backpropagation, the first models were built. There were models the first big contribution was they were able to recognize digits. So we were able to give checks to the banks, and they were without humans being able to recognize the digits, right? That like 90s, and that's first that's Jeff Hinton, Gennady Pekhimenko, Yoshua Bengio works on essentially neural networks, right? That's the first propagation. Then the second big step was invention of deep learning. Because the first neural networks I used myself in 2003 and 2004, they were still very bad in their learning capabilities. So I quickly learned that without enough data, they can't learn much. And they were not substantially better, even worse than traditional, more mathematical, algorithmical approaches to AI, right? But then in 2006, they showed that with enough data and with using a better, more smart algorithm, like convolutional neural networks, you can actually infer way more data from, from like images, for example. That was the second big breakthrough. The only thing that was missing back then, like the algorithms were invented, new models were invented, but there was not enough data, right? So they make a splash, but only locally within the AI community.
Yeah.
But there was nothing that was visible for the outside world. The first big splash happened when all three pillars makes things together. Remember 3 pillars I said: models,
Yeah.
data, and compute.
Yeah.
So what's happened is Jeff Hinton's group and a lot of people other in Canada work on deep learning, right? Yan LeCun, Jeff Hinton, Yoshua Bengio. Then at Stanford, I think Fei Liu built something called ImageNet. So this built the first large data set, which is considered small right now, but that was the first large data set for images. So there were 2 out of 3 pieces already there, and they create a new competition where they can compete who recognizes images the best. There was the third pillar missing, compute.
Okay.
So the story there is Alex Krzyzewski, one of the grad students of Jeff Hinton, was very, unhappy, let's put it this way, that the training of this deep learning model in this dataset takes on CPUs, takes like many, many months. And he was looking, there's a compute that can do core operations like matrix multiplications much better. And he took a course in the engineering department at the University of Toronto from Andres Moshevus, who was teaching a new course on CUDA programming from NVIDIA GPUs.
Yeah.
And he's like, oh, that thing can actually potentially do things better. So this is how things made it to the next level. So the next breakthrough was a thing called AlexNet that a lot of people know. 3 pieces for the first time were together: GPUs and programming model to run them using CUDA. Very primitive, not something like that, but still the best that exists. So the training time reduced from many, many months to just days, right, with a couple of chips, and the data sets and the models. And that was the first visible breakthrough, maybe not to, like, say, my parents, grandparents, but a lot of people in the science community is like, oh my God, like, why was that a big breakthrough in 2012, 2013? Well, there was a roadmap on how well we're going to progress through the object detection. Like, that's the thing that's considered now a solved problem. 10 years ago, recognizing the face or recognizing cat and dogs was not a solved problem. Like, to get you a feeling, the error rate back then was on the order of 20-30%. I don't remember the precise numbers, don't want to lie, but something like that. So humans, in contrast, does that task with 3%, 2% accuracy, error rate, right? So 97, 98% accuracy. So computers were like generations behind, and the roadmap on when we can match with the speed that we were improving the thing by, say, like 0.5% or % per year, the roadmap that would take 20 years to reach the human quality. Like in 2012, we were expecting to get human quality and recognition. The prediction back then was to 2030 something. We would only match humans. In reality, we matched it in 3 years. How that happened, it's the fact that we invented those, like the minute AlexNet appeared, we didn't improve by 0.5% or 1%, we improved by like 10-15% in just 1 year.
Wow.
Plus, we also outlined the roadmap on how to improve further. So 3 next years, people were improving things even further. So Google, a lot of, like, everyone jumped on that. Everyone understands that's the future. By 2015-16, the problem was solved to the level that the accuracy of these models match humans, or even outperform humans, in just 3 years instead of 20. So that was a big breakthrough, right? So that was on computer vision tasks. So object detection, segmentation, for example, finding a car in a moving video, like that, all this type of problem, like computer vision problems. And a lot of them, to an extent, are solvable problems right now. Like, there are a lot of things on how to make it more efficient, but it is as good or even better than humans. That's why self-driving is possible right now in San Francisco. Without that, it won't be possible. And the next big breakthrough was attention mechanism. So essentially, for language, for a long time, we use something called sequential models, because that's a clear mathematical models that we built for a long time based on Markov chains. So essentially, you expect, like, you check how the next word in the sentence depend on the previous one and their probabilities. Unfortunately, this has had quadratic complexity. For anything large, it becomes so big that it doesn't fit in. Like, they will have a lot of computational limitations. The big invention of attention is that you don't need to look for every single word and its dependencies. They can be very like the dependence on this word and that word in the sentence may be very sparse, and you can have shortcuts all over the place. So the attention mechanism. So you were able to train things way better than we will need to do with sequential models. So out of a single language, it becomes within our reach. And then the big breakthrough around attention, it turns out that it can scale. So those models tend like there is a lot of language information in the world that we generate over the years. If you keep feeding it with more and more data, then it becomes. So after that, the transformer model was a big breakthrough. And then OpenAI picked it up. And then the next big thing was GPT-2 model that was open source. OpenAI was still open source back then. And we in academia have seen those models are phenomenally good. Not as good as ChatGPT, but they were clear these things can do where with humans, like we never were seen anything like that before. That's the first time I've seen the text being generated. That's like, oh my God, that looks like close to human, right? It's like, it's just ridiculous, right? That the algorithm can do it, right? And then the next big breakthrough was ChatGPT, which essentially for many of us was not a big change. You just add a human easy interface, the same as Google search, into it. But that changed it because like now the user can be anyone in the world with no experience. Before, to use GPT-2, you need to know Python, right? And use an interface. Like it didn't have an easy interface to use that would be like search box like. But you connect the ideas. How do we search data right now? And with Google search, with the idea of use large language models, and the big miracle happened, right? And the rest is history. So that's a big breakthrough.
Yeah, very captivating story. Thank you so for telling it so interesting. I hope our listeners will find it interesting too. For me, it was really like going through. You mentioned about like the OpenAI being open source at a certain point in time, but then they closed, and then they gave it a easier human centric interface so that everyone can use it. Why do you think they did it? They opened to the world. Was it to get more data, or was it to
there are a lot of
branding to make them popular? What do you think of that?
There are many reasons. I
And why did CentML do the thing for you? You mentioned do you think there are some similarities on the actions?
First of all, you need to understand that the technologies in the similar scale exist in other places. But like say Google was driving like after transformer model that was invented at Google by Googlers, like they all left the company except for maybe one guy as far as I remember, but they were originally there. Then they invented a model called BERT that was another big breakthrough, right? I think Google was just not brave enough. They just thought, because they play with that technology, they thought it's not perfect. So if we get out that technology, regulators are going to kill us for all the misinformation, for all the hallucination it's going to generate. Remember, that's still a problem, right? It's not solved, right? So Google thinks we're going to kill it. And OpenAI has no problem like that. Said, well, let's get that technology in the hands of the people. It's good enough to give it to people, right? And it was done by other companies as well. I think the less successful examples in this space, but like Stability AI did it for Stable Diffusion. They had some issues now, but I mean, they also, like a lot of people had these models. Stable Diffusion models were known in the AI community, but no one was brave enough to give it to people because you can misuse it. It's a very powerful, it's like nuclear weapon. You can misuse it very easily. So you need to be brave enough. You need to get it to the quality that it actually people won't get frustrated from the use of it. So you need that. And it just happens that the quality was so huge and they reached like almost everyone in the world. Like the growth that OpenAI had, no one ever seen the growth like that, right? So that is important. But then I think the direction was we need to commercialize it. We need to generate revenue, which I totally understand. And that was a mismatch between the founders and what they think about AI and about like exploiting your data. CentML, when we created a company, OpenAI ChatGPT was not yet released, but we already use a lot of the models in the open domain, including GPT-2 and all the follow-up models that were open. We know that the need for compute and need for optimization is coming. Why? Because remember I told you about 10x growing models and 2x improve in compute. I was seeing this trend for me is like, oh my God, this things, if it's going to work out, it's going to be so freaking expensive. Someone has to deal with that. And I focus on that. I was focusing on the problem, how to make it commercially meaningful to do it, because right now it's ridiculously expensive, both training and now deployment. And that's what CentML focus is. But for us to be able to do it, we need to make sure that models are available. Like when OpenAI make all their models proprietary and like they offer everything by themselves and try to generate revenue, we can't really help them much, right? They would do it all on their own. But luckily, there is a lot of people that are willing to push the open source models. And obviously right now Matter make a big bet on saying we're going to contribute. But there are other companies like Mistral in France and other like there was a Falcon from Middle East. Those models show that open source community can catch up.
Yep.
And if you think from general perspective, it's very hard for OpenAI having just a couple of thousand of people to compete with the rest of the world when the key principles around the models are clear. Please, the advancements of model year by year slow down. So it means it's easier to catch up, right? So everything they release we can learn from and the whole community can learn from. So in my opinion, the open source models here is the future. And a lot of people who needs proprietary model will build technology to get it out of their foundational free models. So like if you're an enterprise, say a Deloitte and Bloomberg, why would you train and spend $100 million to train a model that just learned what English is?
Yeah.
Just take the standard Llama model that already knows it and fine tune for their specific use case.
Yeah.
And that's like 3 orders of magnitude cheaper.
Yeah. Yeah. Oh yeah, you answered the question. My following up question was that like, what's the motivation for companies for supporting OpenAI? For instance, like why does Meta do it? So you said there's a cost to it. You have to still pay for it, but it's gonna be much.
When you say OpenAI, you mean not OpenAI as a company. You mean
no,
open source AI.
Open source AI. Yes.
Well, I can't speak for Meta, but I think there's multiple things. First of all, they think it's good for society in general. Also, it's a good PR and a good leadership. Like everyone right now is excited about llamas. Like there's like a lineup of people that want to partner with them, and they would find the way to monetize it eventually. The good thing about like Meta doesn't need to generate revenue immediately. OpenAI doesn't have that luxury. Yeah. As a startup, you need to generate revenue right now.
Yeah.
Meta doesn't need to generate revenue right now, so they can just build a good product and build community. So they support Llama's open source. They support PyTorch as a main framework to run these models, also open source. So they support a lot of open source product because it doesn't affect their revenue. They're building something for the future, and eventually they can monetize, right, if they really need. Right now, the licensing on Llama such is only if you had many millions of customers and many requests, you have to start to pay them licensing fees. So for companies like ours, we're not at the stage where we need to pay them any licensing fees. But again, they want to be at the forefront of it, and they have the resources for this.
Yeah,
right.
Yeah, that's so great. During our story, lots of university names came up. You mentioned you famously studied at the University of Toronto. You did your master's degree. You studied at Carnegie Mellon. You did your PhD there. You worked on large language models, computer science and machine learning. And what do you think the role of the universities in the future be? Like, for instance, like you worked in US, you did your PhD, university covered expenses and everything, but you went on to Canada. How do you think the future for university research support should look like? And like, do you think in the current form it looks correct? And what's the role of the universities in supporting such breakthroughs as you mentioned Washington, University of Washington is takes the lead in machine learning, right? If I'm not mistaken.
No, I didn't mention University of Washington is strong, but I wouldn't say they take a lead. Stanford is definitely very strong, in Berkeley, like the traditional top schools, right? Yeah. But there are a lot of other ones. So coming back to the original question, like what the role of university? Well, all these companies need talent. Talent still comes from the university. So first of all, the role of university is to bring that talent that's well versed and has the skill set to help the company. So this is why companies like NVIDIA, Google, Amazon make their hardware available to some of these, programs in our university. So the students learn that. So by the time they get out and go join NVIDIA and Google and Amazon, they actually learn how to run training and inference and other things, right? That's first aspect. The second aspect is I think universities was also that's from undergrad perspective. From the grad student perspective, you want making big bets on things that might not pay out immediately, but have like big fun. The whole AI was like that. No, majority of people didn't believe in that. And there's only Canada was actually back in the day was want to give money to people like, Jeff Hinton, Joshua Bengio to do research on that. Like CIFAR did like some of that original funding. And that pay off at a great scale, right? It's clearly someone needs to keep doing this. So it's governmental agencies and, industry should still give money for academic research to work on foundational problems. And if something starts to become promising, then they will pick up. Right?
Mm-hmm.
So I think university would always be critical to explore things that are more foundational, that doesn't need to get results like tomorrow or next year, but can be done in 5 years, right, or 10 years. So university always going to because companies needs to generate profit right now. They don't afford this type of luxury to invest in something that might not work out, right?
Yeah.
And third thing that's right now, it's like something that is not really working right now is the scale of the problem right now. So essentially AI is very expensive right now. So if you are in academia and you don't work with industry, good luck. You can't really do any meaningful research on like LLMs.
Yeah.
Because just like very basic experiments would require like thousands of GPUs, millions of dollars. This is enormous budgets, right?
Yeah.
So there should be a way to fix this so the academics can actually be meaningful contribute, because right now majority of the innovation in the space is done by like 10 major companies and like a handful of startups, right? That are well capitalized to do this.
Yeah.
And that's something that, the community, like the government and other agencies need to think how to fix this, because it's so expensive. So like people just give up on working in this space, or you need to be a minion of like Google. Like you need to partner with them, or you cannot really do research in that. It's good for them, like interns will come and all of that, but it's like that makes that area of research is almost impossible to contribute if you don't have those connections.
Yeah, thank you so much. It has been a wonderful and really interesting conversation. I have two questions. I usually ask one, but I have two questions. From what we conclude from our conversation today, should we hold on to our NVIDIA stock?
Oh, it's a tough question. I think the most honest answer would be I didn't sold my own NVIDIA stock. Like that's enough.
That's enough and honest.
Yeah, that's a majority of it. And I believe in them very early in the day, so I still retain majority of it.
Yeah, thank you so much. And last question, which I ask here in Silicon Valley, we get used to when we meet people, when you get to know them, the first thing that comes up, like when you describe Gennady Pekhimenko, we say, "Oh, Gennady, he's a scientist. He's a CEO and co-founder of OpenAI. He did this, he did that." So all that describes who you are, right? And famously, a friend of mine said, like, "Hey, I'm more than that. I'm more than what I do. I love ballet. I love the 16th century arts, etc., etc. Like I'm a good father, etc." So without considering what you do, what you have done, who is Gennady?
Oh, that's a tough question. So I used to have a lot of hobbies even during my PhD, but a lot of that as becoming co-founders becomes really tricky. Plus you have family. So I'm definitely a husband and a father of two wonderful kids. Yeah. So that takes a lot, whatever time left from the work, like all of it, right? I'm still a big fan of sports, so I really like table tennis, soccer, hiking. So all of that is still in my radar, and I hope to succeed and get more time, to that. But right now it's just a critical time. It's just you have to spend whatever time needed for the company to succeed. Yeah. But eventually I hope I'm going to get back to more normal life in terms of work-life balance. Yeah. And then older Gennady can spend time on things he also enjoys, like reading books, traveling, and all of that.
Really good. Thank you so much. Thank you, everyone. Today we had a conversation with Gennady, a father, a husband, and a sports enthusiast. Thank you so much for coming.
Thank you.